Exercise 10.3 related with the scalar product of the vectors. But before starting the solution of the questions, it is my request to all of you, like my videos, share my videos and subscribe my channel and press the icon so that you will get my videos as soon as possible and so that you will be benefited. Now let us start the solution of the questions. And here it is given, find the angle between the two vectors A and B. Before getting the angle between these two vectors, you must have to see, suppose it is a vector A and it is vector B. This is, let theta is the angle between these two vectors. Let theta be the angle between the vectors, between vector A and vector B. Okay, and by using the definition, using the condition of the dot product cos theta, repeatedly I have discussed this formula with you: dot product of two vectors divided by their magnitude. By the definition, and it will be equal to, you will have to see, dot product is given root 6 and the magnitude of A, that is root 3, and magnitude of B, that is 2, it is given, and it will be equal to root 6 upon 2 root 3. Okay, let me take root 6, you can write 3 into 2, okay, and 2 root 3, it will be equal to root 3 and root 2. Let me get it separate by using the formula of class 8 or 9. Root 3 will be cancelled. You see, root 3 will be cancelled, it will be root 2 by 2. That is, you multiply numerator and denominator by root 2. Root 2 into root 2, that will be 2 upon 2 root 3, 2 root 2. It will be, 2 will be cancelled, 1 upon root 2. Tell me, in case of cos, 1 upon root 2, it is the value of 45 degree. Or theta will be 45 degree. Or you can say that pi by 4, 45 degree, or pi by 4. Very important question. Let me take another question from the same exercise. Let me take, which is very important. And question number 2. Question number 2, similar kind of question. Find the angle between the vectors. Find the angle between the vectors. Let me write the vectors. What are the vectors? And these are very important cases. Let me take the important case. Find the angle between the vectors. These are the two vectors. Vector A, that is given over here, I minus 2j and plus 3k. And vector B, it is also given over here. Vector B is also given. You will find out its value, angle between these two vectors, 3i minus 2j plus k. And you will find out by using the same thing. But here, before starting the solution, because we will find out the angle between these two vectors, vector A and B, find out the dot product as well as magnitude of these vectors. Because in the previous question, all the ready-made things were given, but here the ready-made things are not given. Then find out magnitude of A. And while you are going to find out the magnitude of A, you will have to take the sum of the squares of the scalar component of the vector. That is 1 square plus minus 2 square. That is the most important thing. Square of the scalar component, that is 1 plus 4 and plus 9. It will be root 14, you see. Similarly, magnitude of B, it will be equal to same thing. Sum of the squares of the scalar components you will write, and 1 square. It will be equal to, that is also same thing, 9 plus 4 and plus 1. It will also be root 14. Using the definition of dot product of two vectors, cos theta will be equal to dot product and their magnitude. But you will have to see the magnitude, dot product of the vectors. Actually, I told you that you must have to find out the dot product of these two vectors by taking the multiplication of the scalar component of corresponding terms. I को I के साथ, J को J के साथ, K को K के साथ में. क्योंकि I dot J, J dot K dot I, it will be equal to 0. If dot product of two unit vectors or two vectors, it is equal to 0. Okay, then what will happen? They will be perpendicular to each other. That is why I dot j will be equal to 0, and you will have to find out the dot product of these two vectors, corresponding element only corresponding scalar components you will have to take. 1 को 3 के साथ मल्टीप्लाई कर दीजिए, इसमें प्लस -2 को -2 के साथ में मल्टीप्लाई कर दीजिए, और 3 को 1 के साथ में मल्टीप्लाई कर दीजिए. 3 and 1 divided by same thing, value of this one magnitude, that is root 14 and root 14. It will be equal to 3, negative into negative positive 4 and plus 3 divided by 14, that will be 10 by 14 cos theta, and theta will be equal to cos inverse, that is 5 upon 7, my dear student. 5 upon 7, that will be its value, cos inverse. That is the angle between these two vectors, vector A and B. That is why it is very important question I am discussing, and you see, find out their magnitudes as well as dot product. डॉट प्रोडक्ट मैंने बता दिया. डॉट प्रोडक्ट में आप लोग क्या करेंगे, आप ये चीज भी यूज कर सकते हैं. देखिए, ये बहुत इंपॉर्टेंट चीज है, दैट इज वेरी वेरी इंपॉर्टेंट. एंड j डॉट j, that will be k dot k, its value will be 1. Second thing, I dot j, j dot k or k dot I, it will be equal to 0, because these are perpendicular. As per the condition, if the dot product of two vectors, whether it may be the unit vectors, is equal to 0, vectors will be perpendicular like that. It is I, it is j. Their dot product, if it is 0, then what will happen? I is perpendicular to j. Same thing we will prove in the question number 5. You see question number 5. Very important question is given, question number 5. And I will write in the short. You see in your book. You can see in your book question number 5. It is a very important question, so that each of the given three vectors is a unit vector. You will have to prove so that vector A, I will write in the short. You can see in your NCERT book. Question number 5 is very very important. Three vectors are given. First vector is 1 by 7, 2i plus 3j plus 6k. Next, vector B is also there. Vector B will be equal to 1 upon 7 and 3i minus 6j and plus 2k. This is the next vector. Vector C is also given over here, 1 upon 7, and that will be 6i and plus 2j and minus 3k. Okay. These are the vectors. You will have to prove that A, B, C are unit vectors. First of all, A, B, C are unit vectors. Unit vectors. How you can say that these are the unit vectors? If the magnitude of the vector is equal to 1. But before starting this thing, you will have to keep in mind k vector A. If you want to find out its magnitude, it will be equal to k and multiply by the magnitude of that vector. Okay, it will not be affected. Then let me find out the magnitude of first vector, vector A. Vector A it will be equal to magnitude. In place of it vector, you will write its magnitude means 1 upon 7. Let me write its value, that is 2i plus 3j plus 6k. Its magnitude. What will be its magnitude? It will be equal to 1 by 7. Okay, and let me take it magnitude of it. You can find out the magnitude. Just before I told you, you will take the square of sum of the squares of their scalar components. 2 square plus 3 square plus 6 square. It will be equal to 1 by 7 root 4 plus 9 plus 36. I think that will be 7 by 7, it is equal to. Therefore, magnitude of A vector it is equal to 1. Similarly, magnitude of vector B will be equal to 1 by 7. Magnitude of B you will take and 1 upon 7. Write its magnitude. Similarly, you will have to write the sum of the squares of the scalar components plus minus 6 square and plus 2 square. It will also be 49 by 7. That is 7 by 7. It will be also be 1. It is also equal to 1. That is why B is also unit vector. Vector C. Let me take 1 upon 7. Magnitude of vector C. It will be equal to 1 by 7. Same thing. And magnitude of B, magnitude of C vector. That will be sum of the squares of their scalar components plus 2 square and plus minus 3 square. It will be equal to root 49 by 7. That is 7 by 7. It will be equal to 1. This thing you must have to keep in mind. Okay? That is why all these three vectors, vector A, B, C, these are the unit vectors. Therefore, vector A, B, C are the unit vectors. Unit vectors. You see how much it is important. In one question, so many questions are there. All these vectors are unit vectors because their magnitude we have got 1. But once again, which is given in the question, you prove that each and every vector is mutually perpendicular to each other. How you will prove? Let me take the second case. You will have to prove the second case in the same question. Prove the second case, second part of it. Vector A is perpendicular to B. This thing you will have to prove. Okay? And vector B is perpendicular to C vector, and vector C will be perpendicular to A is perpendicular to B, B is perpendicular to C, A will be perpendicular to C. All these three vectors are perpendicular. Let me take the first thing. A is perpendicular to B. Let me prove it. If the dot product of two vectors is equal to 0, if dot product of A and B will be equal to, let me find out. It will be equal to vector A. Let you write 1 upon 7. Vector A is 2i plus 3j plus 6k. 1 upon 7 next vector, you will write B vector 3i minus 6j and plus 2k. Very important thing, 1 upon 49. Okay, only dot product you can find out. Only you will have to take the scalar component of the corresponding terms. 2 into 3 you will take plus next 3 into minus 6, okay, and plus 6 into 2. That will be equal to 1 upon 49, 6 minus 18 plus 12. It will be equal to what? 12 minus 12. Sorry, 18. It will be 1 upon 49. 18 minus 18, it will be equal to 0 vector. That is why, therefore, vector A is perpendicular to vector B. Similarly, we will take vector B is perpendicular to C. Similar kind of thing. Let me take the second case. Second case is this one, vector dot product of B and C vector. It will be equal to 1 upon 7. B is this one, 3i minus 6j plus 2k. Dot product with 7. Next vector, C vector. C is 6i plus 2j minus 3k. Okay? Multiply 1 upon 7, 149. I told you must have to take the scalar multiplication of the corresponding terms only. You will have, because I dot I will be equal to 1. 3 into 6. 3 into 6, let me take 3 into 6. And plus minus 6 into 2 and plus 2 into minus 3. See this thing. It will be equal to 1 upon 49, 18 minus 12 and minus 6. It will be equal to 18 minus 18. Okay, divided by 49, it will be equal to 0. That is also 0. Therefore, vector B, it is also perpendicular to vector C. Third case, that is A is perpendicular to C. AC, let me take similar kind of thing we will prove. Because these are very important things. Dot product of vector A and vector C. You will see that is 1 upon 7 A vector 2i plus 3j plus 6k. 1 upon 7, C vector 6i plus 2j and minus 3k. Multiply 1 upon 49. You see, similar kind of thing. Scalar components only you will have to multiply. 2 into 6. See, and plus 3 into 2. And plus 6 into minus 3. It will be equal to 1 upon 49, 12, that is 12 plus 6 minus 18. Similar kind of thing, 1 upon 49 and 18 minus 18, it will be equal to 0. All these vectors are perpendicular, that is why, my dear student, you see vector A is perpendicular to vector C. Easily you can find out if the dot product of two vectors that is equal to 0. Automatically you can say that the vectors will be perpendicular like that. Okay, these will be perpendicular. Now I will tell you